Hello everyone. Today we are going to discuss a software called compiler. In the earlier chapters we studied assembly language programming. Along with the details of the assembler, the details of the assembly program as a language processor were covered. In the earlier days, programs were developed in the assembly and machine language. Special skills were needed in developing, debugging, understanding and correcting the programs. It was difficult to design, understand and maintain the low level machine language programs. With the evolution of assembly language, the programming was made simpler. These languages used mnemonics, which had a close resemblance with the symbolic instructions of the central processing unit. However, a programmer needs complete knowledge of the process instructions before writing the program in machine as well as assembly language. In order to overcome these problems, a need was felt to design programs in high level languages like English. However, the conventional natural language like English is ambiguous as well as complex. The grammar and the vocabulary of the English language are too large. Even with the modern technology, it is extremely difficult for the machine to translate a program written in English to a program written in low level language. Therefore, the designers selected a subset of English language where the main constructs of the program like assignment, control, iteration can be easily expressed using limited keywords and grammars in a high level language program. The translators were developed to accept the text in the language having limited keywords as input and produces text. The translator used to produce text in the low level machine language as output while preserving the meaning of the original source text. A compiler is also a language translator software as it translates a high level language program into a functionally equivalent low level machine language program. The meaning of functional equivalence is that for a given set of inputs, the generated machine level program produces the same output. By the end of 1950s, the machine and processor independent languages were designed. A language for scientific computing called Fortran, which is the short form of formula translation, was designed and its compiler was developed. Because of the compiler, the language quickly became popular due to various reasons. The first, the high level programming languages are much easier to learn and understand. The programmer did not require the knowledge of underlying hardware like the instruction set of the CPU. The second reason for the popularity of the high level language is that a program written in high level language can be easily debugged for errors found if any. The third reason is that the programs are relatively machine independent as compared to low level or assembly language. The fourth is high level languages provide powerful control constructs for iteration. The fifth reason is the high level languages improve the programmer's productivity and reduces the development time manyfold by a factor of at least 10. The sixth reason is the programs written in high level languages are less expensive to maintain than the similar programs written in assembly or low level languages. Considering these advantages, newer and newer high level languages with increasing complexity have evolved in the last few years. The compilers are different for different languages and new programming paradigms like object oriented, functional or logic paradigms. Also, the compilers are customized for different operating systems and different underlying computer architectures like MIPS, SPARC, Intel and ARM processors. In short, the compiler is a software that accepts text in some language as input and produces text in another language as output. However, the important point is that it preserves the actual meaning of text during the translation process. Both input and output languages convey the same functionality. Both the language programs have identical inputs and produce the same corresponding result as output. The input language is called source language, the output language is called the target or object language. Therefore, we can say a compiler is a translator that translates the source program written in high level programming languages such as C, C++, Java and translates them into machine language of the underlying processor such as Intel Pentium 4 or AMD processor machine. The translation process is successful only after the source program is written unambiguously and is free from syntax errors. The syntax errors and ambiguities, if any, are pointed to by the compiler as errors. The translation process does not start until all the reported errors are removed. In the earlier computers, little was understood about the underlying principles, grammars of high level languages, rules of the program statement construction and the fundamental theories behind the compiler construction. The lack of the knowledge on the above made the compiler messy and complex system. Of late, well developed theories like finite automata have made the rules of the grammar easy to understand and implement. The strong theoretical foundation based on grammar rules has mechanized the process of compiler construction. The result is that the reliability of the compiler in the process of translation has increased manifold in the recent years. The compilers are free from bugs today. We have a different compiler for a unique combination of language, operating system and the underlying computer architecture. Therefore, it is essential that the correct version of the compiler must be installed on the system, keeping the knowledge of operating system and the underlying computer architecture for any language you are interested to learn. After the compiler is installed properly, a sample program attached in the installation files must be run to ensure the correctness of the installation process. The important quality of a compiler should be that it must be free from any bugs. You can test that compiler is free from any bugs or installation issues only after you run the sample program. Second quality of the compiler is that it must generate the correct and the equivalent machine code. Third is the compiler must compile fast and the generated code should also be optimized to run in a minimum possible time or minimum number of CPU instructions. The fourth quality of a compiler is that the compiler should display appropriate error messages during the compilation for any syntax errors and also display appropriate runtime error messages if any during the execution of a program. The messages help the programmers to troubleshoot and take corrective action. The process of compilation is that a typical compiler accepts the source program as input. The source program passes through a series of transformation phases, where each phase involves different operations. The final and the last phase results in the executable code as the output. The first phase is a preprocessor. A source program may be divided into modules, stored in separate files and may consist of macros. A preprocessor organizes the modules stored in these separate files in such a manner that the entire code can be efficiently processed by the compiler. The preprocessor thus is not the part of the compilation process. The first task of the preprocessor is to copy the contents of all files, preserving line numbers from individual files. Sometimes new language features are added in the compiler. In order to manage with the old compiler version, the preprocessor converts the new feature functionality into equivalent old feature functionality, so that the old compiler supports the new features. The preprocessors are also used to add new functionalities to extend the language by built-in macros. For example, a language is extended so that it supports access to the database through SQL. After the preprocessor processes the task, the next step is the lexical analysis. The lexical analysis phase scans the input stream of characters into a stream of tokens and constructs a symbol table which is used later for contextual analysis. The tokens in high level language include keywords, identifiers, operators, constants, numeric, character and special characters, comments and punctuations, symbols. The lexical analysis phase divides the source program into logical unit called tokens. Thus, the input to the lexical analysis phase is the source program and the output is the stream of valid tokens. After the source program is divided into logical tokens, the next phase is the syntax analysis. The syntax analysis phase checks the syntax of a given statement. The syntax of a language specifies the grammar of the language. If any token of a source program is not from the standard keyword library or does not follow the precedence rule as specified in the grammar, an error message is generated by the compiler. The next phase is the semantic analysis. After all the errors in the syntax analysis phase are removed, then only the semantic phase starts, and in this phase checks are performed to ensure that parts of the program fit together meaningfully. That means, the phase checks whether the output generated by the syntax phase is meaningful and can be converted into machine code. For example, given a statement A plus B. Let us see how a parser and a semantic analyzer work. Looking at the expression, the syntax phase looks at the binary addition and checks for the presence of operands before and after the symbol plus. The presence of two operands confirms that the syntax is right. However, the semantic analysis phase detects the operands A or B are of type integer or float and therefore, can be added without difficulty. However, if one of the operands A or B is an array or function, an error message is displayed in the semantic phase. The semantic phase ensures that the operand specified with the operator should be compatible, so that the operator can operate on the specified operands. The next phase of the compilation is the intermediate code generation. The intermediate code is generally an abstract language. The compilers of different languages may generate the intermediate code in the same language. Therefore, the purpose of this phase is to provide an independence from analysis phase, which is the front end process, to the synthesis phase, which is a back end process. The generated intermediate code gives opportunity for optimizing the code and generates an efficient machine code which can run faster in the machine. The intermediate language program should have two important properties. First, it should be simple and easy to generate, and second, the translation from the intermediate code to machine code should be straightforward. The next phase of the compilation is the code optimizer. The compile time code optimization involves the static analysis of the intermediate code to replace the costly operation into its equivalent cheaper operations. The meaning of the cheaper operations here is, the cheaper operations take less time to execute and they sometimes take less memory. The equivalent operations take less instructions as well as occupy less memory space, making the code run faster. The last phase of the compilation is to generate the target code. In order to generate the machine or the target code, the designer should have the complete knowledge about the target machine architecture, its instruction set, variable allocation in the memory as well as the registers, program layout and the syntax of the machine instructions. Thus, we have seen the compilation is done in the 6 phases. First phase is lexical analysis phase, which breaks the code into tokens. The syntax analysis phase checks the syntactic structure of the source code. In other words, it focuses only on the form or the structure. It identifies the order of the tokens and build hierarchical structure called parse tree. The semantic analysis phase recognizes the meaning of the programming constructs and prepares the output. The fourth phase generates the intermediate code. The fifth phase performs the code optimization, which helps to reduce the number of instructions, taking less time and memory without compromising on the meaning of the program. The code generation is thus the final phase of the compilation and requires the knowledge of machine instruction set, variable allocation in the memory and register, program area in the memory and other machine aspects. If a compiler runs on one operating system platform running on one processor architecture and generates code to run for another operating system platform on a different processor architecture, it is called a cross compiler. For example, a compiler on a Windows platform generating code to run on an Android operating system on a smartphone, it is called a cross compiler. The another variant of the compiler is the interpreter software. The interpreter was written for the initial high level languages like BASIC. The interpreter interprets each and every line of the source program and executes the line without actually generating the equivalent machine code. The interpreter software maintains all the memory variables and performs the updations to these variables as done in the source program. Therefore, the output of the source program, the final value of the modified variables as a result is same as if the compiler actually executes the program. The interpreter is simpler to design as compared to compiler and does not require knowledge of the underlying computer architecture as no machine code is generated. The advantage of the interpreter is that during the execution of a program, if a line is found faulty or giving incorrect result, the line can be corrected and the program can continue from that line onwards. However, one of the main disadvantages of the interpreter is that it is quite slow as compared to the compiler. In short, the interpreter may be good while learning a language or during development time only. The compilers are useful when the application is simultaneously accessed by a number of users and requires fast performance. In short, what we have learnt is the brief history and evolution of the compiler. Then we studied the installation and the troubleshooting issues of the compiler. The design and the 6 steps of the compilation process were explained in brief. The variants of the compiler like cross compiler and interpreter were introduced. Thank you.